All right, everyone. So today we're starting our new chapter on rational functions. Okay, so our goal is to take this equation or one similar to it, and eventually we want to be able to graph this without using a calculator. Okay, so I think you'll end up liking this chapter because it makes us feel really smart because we're going to take something that looks super complicated and break it down into something that we can understand, and we can draw a nice clean graph without using a calculator and quicker than we could if we even wanted to use a calculator. Okay, so this is called a rational function. Now, what makes this a rational function? So a rational function is when we have a function that has a polynomial in the numerator and a polynomial in the denominator. Okay, so it's when we have a fraction. To simplify the terms here, we have a fraction with some sort of equation on the top and some sort of expression on the bottom. Okay, so this is called a rational function. So my first question for you is, who's my parent function that's a rational function? You guys remember? So before we even think about this guy, who's my parent function that we know something about that's a rational function? And so hopefully you remember f of x equals 1 over x. Okay, so that's my parent function that lives in this same family. Now this is the very simplified version of what's up here, but it's rational, right? We have some sort of expression on the top, we have an expression on the bottom, and this creates some sort of rational function. So my first question for you is, what are some things that you remember about this parent function? Like, what were some features that this graph had? Do you guys remember what this looked like? So if we remember what this graph looked like, we had a vertical asymptote, remember that, at 0. We also had a horizontal asymptote at 0. And then if you remember the general shape of my graph, it lived down here in the third quadrant and up here in the first quadrant. So this was my parent function 1 over x. So my family of rational functions are all going to have some of these same key features here. We're going to have, we might have some x-intercepts, we might have some y-intercepts, but we're going to have vertical asymptotes, we're going to have horizontal asymptotes, maybe other types of asymptotes that we'll talk about. But this is the family of functions that we're talking about. All right, so today we're not going to make it all the way through to graphing this function just yet. We're going to break it into smaller pieces. But today my goal is I want to know what are the x-intercepts of this, or are there any? I want to know the y-intercepts. How can we find the y-intercept of that function? And I want to talk about how could I find the vertical asymptotes. Okay, so we're going to talk about horizontal asymptotes a different day. We're going to talk about how do I know where to put the function. How do I know where to draw the graph? We'll talk about that next time. So today is just x-intercept, y-intercepts, and vertical asymptotes. Okay, so before we start looking at our first example, let's just try to break this down into smaller pieces. So let's think about just fractions. So I want you guys to think about the fraction a divided by b. Okay, so just two numbers. It's just a fraction. Don't worry about any expressions or x squared or anything like that. Let's just think about a over b. So I want you guys to think, what would happen if a was equal to 0? So what happens to this fraction if a is equal to 0? So if the top of that fraction is equal to 0, what does that tell you about a divided by b as a whole? Well, if a is equal to 0, that'd be 0 divided by some number, which would be equal to 0. So if a equals 0, then that means that a divided by b is going to be equal to 0, assuming that b is some sort of constant. Okay? Alright, so we'll come back to that in a second. What if b is equal to 0? So let's say a is some number, like 3, but b is equal to 0. Then what does that tell me about a divided by b? Well, that means that A divided by B would be undefined, right? Because we'd have some number divided by 0, which is undefined. So how does that translate into a graph? Well, let's look at a nice, easy example here. So let's start with f of x equals x minus 1 over x plus 3. So let's break this down and let's see if we can figure out what's happening in this function. So let's start with this. We said if the top is equal to 0, then the function is equal to 0. So how do you think that translates here? If the top is equal to 0, then that means the output is going to be equal to 0. And what do we know about when the output equals 0, what's happening on my graph there? Well, anytime I have a graph and my output equals 0, that means I'm on the x-axis here, which means that I have an x-intercept. So when the numerator equals 0, we have an x-intercept. Okay, so when the numerator equals 0, we're going to have an x-intercept of these functions. Which means I don't need to look at this whole complicated thing. All I need to find the x-intercepts is just to look at the top. So what is going to make the top equal to 0? Well, I could just set the top equal to 0. X minus 1 equals 0, which means x equals 1. What's happening at x equals 1? This is going to be an x-intercept. Okay, so I don't know what the rest of the graph looks like, but I know when I graph this, I'm going to have an x-intercept at 1. Okay. Okay, so when the top equals 0, we have an x-intercept. So what do you think is going to happen when the bottom equals 0? Well, if we come back to our fraction example, we said when the bottom equals 0, our function is undefined. And then come back to our parent function. When the bottom equals 0, we get undefined. Okay? So what do you think that's going to translate to in this problem? Well, when the denominator equals 0, we are going to have a vertical asymptote. Okay? And remember, the purpose of a vertical asymptote is to say, my function is not defined here. We can't cross over that vertical asymptote because it's not my domain. That value is not my domain. So what would that be in this example? Well, we would set the bottom equal to 0, x plus 3 equals 0. So x equals negative 3 would be a vertical asymptote. So on my graph, I'd go to negative 3, and there's my vertical asymptote. Okay? So here's the key so far. X-intercepts is when the top equals 0. Vertical asymptote is when the bottom equals 0. All right, let me clean up my board, and we'll go to round 2 here. Okay, so I think we're ready to start talking about this guy over here. Okay, because if we follow the same procedures that we just followed, then the only difference here is we just have to remember some algebra 2 facts here. So let's recap what we said. I'm going to start by finding my x-intercepts. So how did we just say we find our x-intercepts? So we find our x-intercepts by figuring out when does the top equal 0. Or if we want to be fancy, we could say the numerator. So we're going to find it when my numerator is equal to 0. Alright, I can do that. So x squared minus x minus 6 equals 0. Well, how do I solve this? Well, this is a quadratic, so we could do quadratic formula, we could graph it and find the x-intercepts, or I made this a pretty nice and neat function. Let's just see if we can factor real quick. Alright, so I know it's been a while, but I think we can do it. So how do we factor this? So I need numbers that multiply give me negative 6, but add to give me -1. So I think that's -3 plus 2. -3 times 2 is -6, but -3 plus 2 is -1. So there's the factor version. And then if I'm trying to solve for 0, I'm going to set both of these equal to 0. So I get x equals 3 and x equals -2. So these values that I just found are going to be my x-intercepts on my function. I found them. You guys found them. Nice job. Okay? So to find my x-intercepts, we're just going to set the top equal to 0, and then we might have to remember some algebra facts like that. All right. So there's my x-intercepts. Well, what about my vertical asymptotes? Well, what did we say a minute ago? We said in order to find the vertical asymptotes, I'm going to set the denominator equals 0 or the bottom equals 0. Okay, I can do this. So I'm going to set the bottom equals 0. So x squared plus 7x plus 12 equals 0. All right, flash back to algebra 2, maybe in algebra 1. So I got to factor this. All right, so I need two numbers that multiply to give me 12, that adds to give me 7. That sounds like plus 3 plus 4. All right, sweet. So now I got to solve for x. So x equals -3 and x equals -4. These are my vertical asymptotes, my VAs, my vols. Right? So there we go. We're doing a great job here. So I'm going to think about sketching this here. So let's see what we got. So if I wanted to put this all together, I have an x-intercept at 3. I have an x-intercept at -2. I have vertical asymptote at -3. And a vertical asymptote at -4. Oh, wow, this is going to be a goofy looking graph. It's a good thing I don't have to graph this today because this would be weird looking. But there's the beginning of my graph. Okay? So I found my x-intercepts. I found my vertical asymptotes. And then there's this one more thing that I want to make sure that we know how to do today. This one should be pretty harmless. I want to find my y-intercept. Okay? Now, if you remember anything about graphs in general, this should be pretty painless. How do you find any y-intercept ever in your entire life? Well, think about what a y-intercept is. Y-intercept is where the graph is crossing the y-axis, right? And what do we know about all the points that are on the y-axis? We know that this happens when x equals 0, right? Anywhere on this y-axis here, my x value is 0. So all I need to do is plug in 0 for x. All right. So really I'm finding f of 0, plugging in 0 for x. So 0 minus 0 minus 6 over 0 plus 0 plus 12. So I get -6 over 12, which equals -1/2. So my y-intercept is -1/2. Okay, cool. So now I have all of these good points to work with, and in the next video we'll talk about how to graph this. So I'm going to pause and do one more example. Okay, so our last example here, x squared plus 3x plus 2. I want you guys to pause the video so you can find x-intercepts, y-intercept, and vertical asymptotes. So I'll give you a minute. Ready, pause. Okay, so x-intercepts, I set the top equal to 0. I got to factor this guy. So this would be x plus 2, x plus 1. So I get x equals -2 and x equals -1. So there are my x-intercepts. Nice job, team. Vertical asymptotes. I set the bottom equal to 0. So x minus 1 equals 0, which means that I'm going to have a vertical asymptote at x equals 1. All right, no big deal there. And y-intercept, we plug in 0 for x, so we're going to find f of 0. So if I plug in 0 for x, I get 0 plus 0 plus 2, all over 0 minus 1. 2 over -1 is -2. So f of 0 equals -2. All right. Nice job today, everybody.